Hello everyone, my name is Subham and in this video we will discuss a very good problem on inequality. So this inequality problem is based on a right angle triangle which is right angle at C, means angle C is 90 degree. Then we have to prove that a to the power n plus b to the power n is always less than c to the power n for all n greater than 2. So this is my right angle triangle, 90 degree at C. C is the length of hypotenuse and A and B are the length of other sides. Now if you see that there is a condition on n, that is n is always greater than 2. So what happen if we take n equal to 1? Then this inequality become A plus B is less than C. But this is actually wrong. Why? Because we already learned a property of a triangle that sum of two sides of a triangle is always greater than the third side. So A and B are the two sides length. So this sum will be greater than the third side length. So this is actually true. Now what happens if we take n equal to 2? Then this inequality will give a square plus b square is less than c square. But if you see, then this is also wrong. Why? Because the right angle triangle will satisfy the Pythagoras theorem, and Pythagoras theorem said that a square plus b square is always equal to c square. That's why we are taking n is greater than 2. So let's verify for n equal to 3. See, without loss of generality, I will assume that A is less than equal to B. And by right angle triangle property, we know that this A is strictly less than C and B is strictly less than C. So for n equal to 3, what we have to show that AQ plus BQ will be less than CQ. Now to prove this, I will use Pythagoras theorem, that is A square plus B square is equal to C square, right? Now if I multiply with B on both sides, then we will get BA square plus BQ is equal to BC square. Now see, we know that A is less than equal to B. So A into A to the power R will be less than equal to B into A to the power R, right? And B is less than C, so B into C to the power R will be less than C into C to the power R. Hope you understood these two cases. Now if we use this result, then what will happen? This BC square should be less than C into C square, and that is equal to, right? Now so we have BA square plus BQ is less than CQ. Now this BA square is greater than AQ. So this is AQ will be less than equal to BA square. So this will imply that AQ plus BQ will be less than CQ. So hope you understood for n equal to 3. So this is the proof for n equal to 3. Now we will assume that this inequality is true for n equal to k. Then we will get a to the power k plus b to the power k is less than c to the power k. Right? Now I want to prove that this is true for k plus 1 also. So to prove that, what I will do, I will multiply b on both sides, because b is positive, so it will not change the inequality, right? So we will get b c to the power k. Now with this property, we can say that this should be less than c to the power k plus 1. And with this property, that is a into a to the power r is less than equal to b into a to the power r. So I can write a to the power k plus 1 plus b to the power k plus 1 will be less than equal to b into a to the power k plus b to the power k plus 1, and that is less than c to the power k plus 1. So clearly we get that this a to the power k plus 1 plus b to the power k plus 1 is less than c to the power k plus 1. Hence, by induction, son, a to the power n plus b to the power n is less than c to the power n for all n greater than 2, right? So this is the proof for this problem. So hope you understand this proof.